Spotify knows how I am feeling now via Semantic Kernel. So let me officially start. So hello everyone. So welcome to my Spotify and Semantic Kernel session. Today, I'm going to use the Semantic Kernel to automatically generate a playlist on Spotify. So my name is Justin from Microsoft as a Principal Cloud Advocate. So these are my social media handles. So follow me on those media and you will find out many talks about .NET, Azure, Cloud Native, and AI stuff. Okay, so let's get started. So as my session title says, it sounds a little bit strange about the combination of Spotify and the Semantic Kernel, doesn't it? So why and where did I start this? Sure. When you are working at the office or at home or do some workout at the gym or whatever situation you are in, if you like to listen to music, then searching or creating a playlist is kind of inevitable. So, for example, if you like K-pop, like me, you probably search a playlist about K-pop on YouTube, or search the same keyword on Spotify or whatever service you like. Then there will be a bunch of playlists like this coming up. Personally, I like them all. I just pick up any playlist I want. However, there is a slight problem on each playlist. It's not problem exactly, but kind of problemish, because I didn't create those playlists. It's mostly fine, but slightly off from my preferences. And most importantly, some playlists are out of date and or no longer maintained. So like I want to have my own playlist with the latest music tracks. But at the same time, I don't want to spend too much time to create those kind of playlists.
Right.
So if someone or something create the playlist on my behalf based on my current feeling input, right? That would be really awesome, wouldn't it? So I started some research for it. Fortunately, there is an official account of Billboard on Spotify, and it provides Billboard Hot 100 playlist. Billboard Hot 100 tracks playlist, which is regularly updated. So, we all know that we can use LLM like OpenAI to handle my request in natural languages. So I'm going to use OpenAI API to analyze my sentiment from what I enter. Then the analysis of my sentiment can be sent to the Spotify API to pick up songs and create a playlist for me. But instead of randomly picking up songs from Spotify, I'd like to provide the Billboard Hot 100 tracks as a bias data, which is like rock pattern, right? So the overall architecture might look like this. So I have a UI screen that accepts user input, something like, may the force be with you. Then that the sentence or that sentiment is going to be sent to the OpenAI API. Actually, so it can be any LLM. I just chose OpenAI. So the user input goes into the LLM inference API to analyze those sentiments. Now, as I said, I just use Azure OpenAI, but you can basically use any LLM that Semantic Kernel supports. And finally, that LLM analyzes my sentiment, then that sentiment is going to be sent to the Spotify API and generate the playlist for me. Right? That's that simple, isn't it? Another interesting API that Spotify offers is the audio features. If I send a track ID of any Spotify song, it returns the feature analysis result like this. So it contains many attributes like liveness, loudness, tempo, acousticness, whatsoever. But of all that, I noticed two attributes, which is danceability and valence. So according to the API document, danceability indicates whether the song is good for dance or not. The value is between 0 and 1. So the higher the value is, the more danceable. The lower the value is, the less danceable. Like not many movement or something like that. And similarly, valence identifies whether the song is positive or negative. So if the value is close to 1, it's more positive. And if the value is close to 0, it's more negative, right? So this really gives my some sort of inspiration. So that means through LLM, we can convert our sentiment into numbers, right? So we can quantify our sentiment into numbers. Therefore, based on the research before, this is a solution. I can build an application. So first of all, I enter my current feeling, like, may the force be with you. Then an LLM analyzes its sentiment. For example, is solidarity. Then the LLM also converts the sentiment into the numbers of danceability and valence, right? And the LLM uses the Billboard Hot 100 tracks as the base data. It picks up relevant songs within the base data, having those danceability and valence range. And finally, the application creates a playlist through the Spotify API. Sounds interesting, yeah? So while building this application, the LLM takes care of those steps, like sentiment analysis and quantify the sentiment and song selection. Then how do we orchestrate all those steps? That's what Semantic Kernel does for us, right? So let's talk about the Semantic Kernel. Actually, I'm not going to talk about Semantic Kernel too much details here today because it's not just about Semantic Kernel session. It's more about how we utilize Semantic Kernel to build an intelligent application. So just to be simple, the Semantic Kernel helps AI be seamlessly integrated into your applications. So Semantic Kernel provides its SDK in 3 major languages, Python, Java, and .NET. Therefore, you can build applications with Semantic Kernel with almost no limitation. So today, I'm going to use .NET SDK. And if I say like this, Semantic Kernel, and this is open source, run by Microsoft, then the people's perception is very interesting. And this is a commonly asked question to me about whether, okay, does the Semantic Kernel only support OpenAI or other OpenAI and not anything else? So that's a common question to me. Actually, this is not true. There are many LLMs Semantic Kernel supports like this. Both OpenAI and other OpenAI, of course, Semantic Kernel supports. But at the same time, Ollama, Hugging Face, Mistral AI, Google Gemini are also supported. And recently, GitHub models are also in support. And the good thing is, both Hugging Face and GitHub models support is a big win because both use OpenAI Inference API and both host many LLMs. So therefore, as long as any large language model is on either Hugging Face or GitHub Models Marketplace, you can use it for the semantic kernel integration. It's really powerful feature. Right. So I had too much talk. So it's a demo time. So I'm going to show you how Spotify generates a playlist on my behalf by reading my sentiment. So for this demo, I'm going to use polyglot notebooks. So it's because I can show you step-by-step approaches, and it supports C# and other languages, not only just Python or Ruby. I mean, Python or R. Right. So let's go into here. Okay. So these are the polyglot notebook here. And first of all, I'm going to install those NuGet packages. So here, this is the .NET 9 NuGet packages and also other semantic kernel packages and Spotify APIs and something like that. So I already installed these kind of things. Now, I'm going to use the add all the using statement here. Then I will add the access keys. I'm not going to open this app settings file because it contains everything. So I'm not going to open it, but I will just import it, right? Then this time I'm going to use Google Gemini. So within the app settings file, it has configuration of Gemini, API key, and model name. So if I click here, then it creates a semantic kernel instance like this. Then if I click this one, who are you? Then it says, oh, yeah, I'm a large language model trained by Google, right? So this is how we can identify what kind of a large language model we are going to use and within semantic kernel, right? And now this time, I'm going to use the Azure OpenAI GPT-4 only model. So the same thing, I can add the endpoint API key and deployment name. Now, only the differences between the Google Gemini and here is that just the kernel builder, and then we just add Azure OpenAI chat completion method, right? And here, Google Gemini is add Google AI Gemini chat completion. This is the only difference. Then, so I added it. Now, can you see that? Invoke prompt async. So everything, so after the semantic kernel instance is created, then all the usage is basically the same, regardless which language model we are going to use, right? So we just use run the sample and the same prompt here. Then who are you? Then it says, okay, I'm artificial intelligence created by OpenAI, which is good. Yeah. Now, another one is that I'm going to use GitHub models, and this time I'm going to use 3.5. And this time we create the same the kernel builder, then OpenAI chat completion. That's very interesting, right? Because GitHub models uses OpenAI Inference API, the same Inference API structure. So we just simply use the GitHub token and endpoint, and that's all about and create OpenAI client. So if I use this, then everything is okay. Then I just simply call the same method. Same prompt and through the same the method. So it says, okay, I'm fine by Microsoft. So we have created 3 different kernel instances with different models, right? So yeah, so this is how we can, orchestrate all different the large language models into the semantic within the semantic kernel. So this is a fun part to start, right? So I'm going to start orchestrating all the things to create a Spotify the playlist. So here I'm going to import the Spotify prompt here, and also this is based on the text, the prompt, and these are from the native code, which is written in C#. So I'm going to import everything here, and also I'm going to import, create some sort of dependencies here. So edit it now. It says, so I'm going to get the user input. How are you feeling today? So here, so it says, okay, may the force be with you. So this is my current feeling, right? May the force be with you. Now, what I'm going to do now, so I have prepared everything. Now we are going to orchestrate all the prompt and native code with this order. So first of all, with this feeling, I'm going to get the sentiment. So I'm going to analyze my sentiment, then convert into the numbers, the third one, and it will return multiple sentiments. So I will ask the large language model to pick up one primary sentiment. Then for the better prompt, I will refine the question, and I will get the base data from the Spotify and find songs and refine results and create playlists. When you see the number 5 and number 8 is going to use the native code, and all the others use prompt, which means prompt means we are going to use large language model. And number 5 and number 8 uses just the normal C# code. Okay, so now I'm going to use kernel 3, which is run by Pi 3.5. So okay, so if I run this, then may the force be with you is analyzed into something different. Okay, so optimism, supportiveness, encouragement, unity, blah blah blah. So this is the analyzed by Pi 3.5. Now kernel 2, so I'm going to use the OpenAI. So this sentiment is converted into the numbers. Okay, here we go. Then it will be converted into these tables, right? So if I open measure sentiment here, so this is actually the prompt here. So you are an expert of quantifying sentiment into numbers. So I put personas into this prompt, which is I build an agent. And every other the prompt has also a similar persona, and I put different agent, different personality of that agent. And I put some sort of fusion example here to like with this input, and it will be formatted like this type of table format. Okay, so it actually turned into like this. Now there are so many sentiments analyzed, so there are too many. So I also asked to pick up primary sentiment. Now, so if then okay, it has the pick up the supportiveness, and the funny thing is that it also returns a JSON format, which will be used in the next the function call. Now, so with this information, I'm going to refine the question. So like this, then okay. So list all the songs with valence between 0.6 and 0.8 because it has valence of 0.6 and 0.8 here. Okay, so the question is all refined. Now, I need to get all the data from the Spotify, right? So this is the one that I'm going to use. So I'm going to get the Spotify data, and this one is that. So how can I get this one? This is the one. So this is get chart, and I put HTTP and JSON serialized options as a dependency, and also I get the chart name here, and this is the main part. So I just simply get the JSON data from somewhere, right? I already pre-built the format, but we can imagine that we can replace this part into your database code or your internal API code to get the base data, right? So this is something we can do within the native code. Okay. Now, so we get all the data. Then this is the main part, find songs. So based on the 100 the songs here, and then I have the sentiment analysis. Then, okay, so let's send a request. So to get the results. It takes a little bit of time. There are a bunch of other ways. So I just simply use the GPT-4 only, but there might be other embedding the approaches, but I've just simply used this approach. So it takes a little bit of time because we put a lot of data as a base data. So hopefully it never going to the timeout error. But yeah, we get that. So we got all the songs, and let's check it. Oops. Let's check it. Where is it? Okay, valence between 0.6 and 0.8. So 0.6, 0.6, something like that, right? So we got all the data between there. So from the 100 songs of Billboard Hot 100 tracks. Now, so based on this data, we need to create the Spotify playlist. So before that, we need to refine the result. So I get another the LLM, the prompt. So to refine the result, and it will be turned into some sort of the record format, which is track ID of this song, track ID of this song. So we can easily find out Spotify. So now we are going to create a Spotify client for the API call, and we get that. Then this is the main thing. So we create a playlist. Now we have created a playlist like this. So if I click this, then then we have my sentimental playlist just created 12 seconds ago. Okay, so we have the playlist, and these are 11 songs. And where is it? So these are a list of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. So based on these the result, the Spotify generate the playlist for me, and this list was picked up based on my sentiment. Right. So this is how we are doing. So this is the end of my demo. So how was it? Now, oops. So my talk is about the close to the end. So let's pack this up. Throughout this session and demo, I showed you how to create semantic kernel instances using different large language models. Then, how to connect to those large language models, including like OpenAI and GitHub models and Gemini, and how to integrate prompt and native code as a plugins, and how to put personas as an agent into each prompt. And finally, how to orchestrate them all. So today, I only showed you a manual orchestration, but when you look into the semantic kernel feature, there will be the automatic function call, so automatic planning, automatic orchestration, the features in there. So, so you might like to have a look at these kind of things. So yeah, that's the end of my talk. My talk is particularly not tied into .NET 9, even if I use .NET 9. However, if you use .NET 9, it would really show you much better performance. And if you want to know more about the semantic kernel, this is the link, and please take a look the ika.ms/semantic kernel, and please play it around. Then you will understand it is so powerful. I just showed you a very small part of the features of the semantic kernel offers. So please take a look at the semantic kernel page. Right, that's it for now. So there is a QR code on the right-hand side for this session survey. So it would be really great to take this QR code and leave your thought. Thanks for listening.